It says Sam and Jill decided to explore a city. Both begin their walk from the same starting point. Sam walks one block, okay. If all city blocks are the same length, who is the farthest distance from the starting point? All right, so let's do this. We got a starting point right here. One goes north, one goes south. All right, so let's go one block north, one block east. Try to make these the same length as close as possible. 3 blocks north. 1, 2, 3. Yeah, sure. And then 3 blocks west. So 1, 2, 3. All right, and then we have. So this is 4 blocks north. This would be 2 blocks east, 4 north, 2 east. Total. Okay, Jill walks 4 south. 1. Oh, so if she's going south, then this would be 1 block west. Goes back 1 block north, and then 4 blocks east. So this is a total of 3 blocks east, I guess. And that would be 3 blocks north. And so what we're going to try and find out is we need to see who's the farthest away. So from here and here, who's the farthest away? So this, the power of algebra is what this lesson is called. It's called finding Pythagorean triples. So all we would do is to take this 2 east and say 2 squared plus this 4 north, 4 squared equals, and see what it equals. And then here we would take this 3 squared plus 3 squared and see what that equals. Okay, so that's 4 plus 16, so that's 20. Since a squared plus b squared equals c squared, we'd have to square root that. And then a squared plus b squared equals c squared. So we'd have to square root that. So what is that actually going to be? Well, I think we can already tell that he is, or Sam, yeah. Sam's farther away because this number is bigger than this number. So let's just go ahead and call it that Sam's farther away. We don't actually have to figure that all the way out. Okay. So now we're going to prove that if x is greater than 1, then a triangle with sides x squared minus 1, 2x, and x squared plus 1 is a right triangle. Now, you should know that x squared minus 1, x squared plus 1 is going to be the conjugates. Right? They're the conjugates of what? Conjugates are difference of 2 squares, right? So let's see how that works out. So, got to do a little thinking here first, I guess. And we have a right triangle. I guess we would have to say, well, here's the tricky part. We have to know what's the longest length. So which one of those is going to be the longest length? Well, I think if we square x plus 1, that's going to definitely be the longest length. It's definitely going to be more than 2x. And it's got to be more than x squared minus 1. So I think we're good there. X squared minus 1 up here. Now, too bad it doesn't work out to where we're just multiplying the two conjugates together. No, we have, this would be a squared, this would be b squared, and this would equal c squared. So let's do that. X 2x squared plus x squared minus 1 squared is equal to squared plus 1 squared. Now, so let's see what that looks like. That's 2x times 2x, which is 4x squared. And this is going to be x squared minus 1 times x squared minus 1. So that's going to be x to the 4th. That'll be let's just go plus x to the 4th. If we combine the outer and the inner, that's a negative x squared. So we'd have negative 2x squared. They're going to be the exact same here. And then that's going to be a plus 1 if we do our last there. Okay, and so that's got to equal, same thing here, x squared plus 1 times x squared plus 1. So it's going to be x to the 4th. And then we got positive x squares for the inside and the outside, or for the inner and the outer. So that's going to be plus 2x squared and then plus 1. So we got to, this has got to be equal somehow. Oh, it is. Okay, this will be x to the 4th. And if we combine these like terms, that's a negative 2x. So 4x minus 2x is a positive 2x squared plus 1. And that works out. X to the 4th, just bring all this over here down. That's the exact same. That's why it works. Math is so amazing. All right, so think about Pythagorean triples. Pythagorean theorem, a squared plus b squared equals c squared. So let's look at it. Next, we describe an easy way to find Pythagorean triples using expressions from example 1. And example 1 is what we just did. Look at the multiplication table below. 1, 2, 9. Notice that the square of 1, 4, 9, and 81 lie on the diagonal of this table. What value of x is used to generate the Pythagorean triple 15, 8, 17? By the formula, x squared minus 1, 2x, x squared plus 2. How do the numbers 1, 4, 4, 16 at the corner of the shaded square in the table relate to the values of 15, 8, and 17? Okay, give me just a second. It's been a little bit for me to do this. Okay, I think I remember now. We have, these are x's. So that would be our 2 x's. So that would be 2 times 4. Yeah, so that would be 4s, 2 times 4. So that'd be 4 plus 4, or 2 times 4, right? If we use that as our x. So that'd be 2 times 4. Now, if that's the case, then our x squared is our 16. So we would have 16 plus 1 and 16 minus 1. Okay, that's the same thing as our x squared. 4 squared is 16. So there we would have our 15. Here's our 17. Yeah, that's right. And there's our 8. Okay, so what's in the graph is basically what's at the corner. The same numbers at the corner are going to be your x's. Okay, let's look at the next one. Now you try one. Form a square. Okay. Let's do this big one here. Let's do 9. Let's do 9, 81, 9, and 1. Right? So that would be 2 times 9. 9 squared, 9 squared, plus 1, minus 1. So this is 18. This is going to be 81 plus 1. So that's equal to 82. 81 minus 1 is 80. So there you go. So your x is equal to 9. And so this is kind of our cheat. There's our x. Uh-oh. What in the world happens here? See if we can figure this out. Now, I've already said that the corners are the x. So let's figure this out. Oh, let's generalize the square to any square in the multiplication table. Two opposite vertices of the square are the square numbers. Okay. How can you use the sum or differences of the numbers at the vertices of the shaded square to get a triple, as in 16, 30, 34? Is this a Pythagorean triple? Okay, so if we use those at the corner, to get 16, 30. Oh, okay. So here's our 30. 15 plus 15 is 30. Yeah, that's how, okay. 25 plus 9 is 34. And 25 minus 9 is 16. That's pretty neat. Okay. Using x instead of 5, because here's our x, and here's our 3. Y instead of 3, your calculation right down as a generating a Pythagorean. Okay. So that would have been and what they're saying there is we squared 3 squared to get our 9. And we took our 5 squared to get our 25. So they're saying instead of doing that, get our vertices here and here, and then to make it a perfect square around through there, we're just going to use x's and y's. So we would say let's see, what would we say? Okay, so we just said what is this? X is 5, so x squared. 9 is going to be plus y squared equals something. So let's just put that there. This is just going to be the subtraction of it. So x squared minus y squared. That's the difference of 2 squares. Sum of 2 squares. And then these up here, that's 2. Oh, 15 comes from x times y. 3 times 5 is 15. So there's 1, there's 2, there's 3. There's your 3 sides. Is that it? Sure, that's not all the home, or not all the classwork. It is. Okay. Pythagorean theorem, sorry. If a right triangle has legs of length A and B units and the hypotenuse of length C units, then a squared plus b squared equals c squared. Converse to the Pythagorean theorem, if the A, B, C of the sides of a triangle are related by a squared plus b squared equals c squared, then the angle opposite of the side of length C is a right angle. Okay. It's basically the reverse of that. Pythagorean triple. The Pythagorean triple is a triplet of positive integers, a, b, and c, such that a squared plus b squared equals c squared. The triplet 3, 4, 5 is a Pythagorean triple, but 1, 1 square root of 2 is not, even though the numbers are side lengths of an isosceles triangle. Yep, that would be an isosceles, not a right triangle, because here, okay, 3 squared plus 4 squared equals 25. The square root of 25 is 5. So there's your 3, 4, 5. But if you did 1 squared plus 1 squared, that does not equal the square root of 2. Square root of 2. Because 1 plus 1 is equal to 2, but this would radicalize inside of it. No. Let me see. Let me go back here. Let me go back here. Equal to. Oh, that's because, okay, that's what that's saying is. When you do this, that's 1 plus 1. 1 plus 1 is 2, not the square root of 2. That's what it's saying. Okay. I thought we came up with an algorithm, or not algorithm, but a formula. Let me see. Okay, this is it. We're supposed to write down a formula right here. Okay, so what we're using is these 3 terms right here. Okay, and we know that this plus is going to be our longest angle. So what we're going to end up with is 2xy squared plus x squared minus y squared equals x squared plus y squared. When we have these charts like this, you can do that to find your answers. I knew there was some formula we needed to come up with. All right, page 7. Let's see here. The homework. X minus 3 times x plus 3. You know that there's the conjugates. There's going to be the difference of two squares, which is going to be x squared minus 9. Guys, by now you should be able to see that in your sleep. That should be super, super, super easy. Okay. The next one is x squared minus 3. That's once again, same thing. Conjugates. What's that conjugates of? Well, x squared is going to be x to the 4th. Here's a squared. A squared is minus 9 again. Let's see here. Same thing for this problem. X to the 15th plus 3 times x to the 15th minus 3. Same thing. Difference of two squares. Now you're sitting here going, but 15, that's not a square. But if we were to multiply those together, then first, outer, inner, and last, the first and the last, those are going to be squared. So what is your x to the 15th squared? Well, oh, yeah, we're going to say x to the 15th squared minus 9. So let's go ahead and do that. X to the 15th squared is x to the 30th minus 9. Remember, we multiply when an exponent is raised to another exponent. You add exponents when they're just multiplied together. This one is raised to a power. So this is your answer. Excuse me, guys. I'm looking to see. Okay, what do we do next? D. X minus 3. And x squared plus 9. What's x plus 3? Okay. Okay. Let's see here. Oh, that's pretty neat. Okay. So I recognize these to be conjugates. So that's going to be x squared minus 9. And then that becomes conjugates there. So that's going to be x to the 4th minus 81. And there's your answer. Conjugates times, or when you get those conjugates there, you get the difference of two squares. Then you have conjugates again, and you have another difference of two squares. See? Short. Now, some of y'all would have sat there and y'all would have done full. You would have fooled these two, and then you would have took that and you would have fooled it by that. And that's the reason why if we recognize these things, we don't have to do that. Let's look at the next one. Okay, now you should be looking at that and going, that is the difference of two squares. Yeah, difference of two squares because it's conjugates. So all I'm looking at is this term and this term. Could care less about the rest. X squared is x to the 4. It's going to be the difference of two squares. So what is y squared squared? Y to the 4. And that's your answer. The next one's not as fun. X squared plus y squared squared. So what that is, let me just do that on the next page because we're going to run out of room. X squared plus y squared squared. Okay. We will just have to Let's just do it. Let's just multiply it out. I don't want to confuse anybody. Should be fairly easy though. The first, x to the fourth. The outer and the inner are both going to be the same. So it's plus x squared y squared plus x squared y squared plus y to the fourth. So all we got to do is combine these two. We have x to the fourth plus 2x squared y squared plus, and I said y to the fourth, but over here I wrote y squared. I don't think it did. Maybe I didn't. But it's y to the fourth. Are you good with that? I hope so. If that didn't trick too many of you. Okay. Okay. Let's look at this. Got x minus y squared times x plus y. Okay. What this is, we can multiply in any, the commutative property says it doesn't matter, we can multiply in any order we want to. So if I have 2 of these and 2 of these, I would have conjugates. I had x minus y times x plus y times x minus y times x plus y. Okay? And if I got conjugates, that means I have differences of 2 squares. Okay? So this would be x squared minus y squared times x squared minus y squared. Okay. Now, all we have to do, first outer inner last, because now these are no longer conjugates. So we got to do first outer inner last, full it. First is going to be x to the fourth. The outer is negative x squared y squared. Inner is negative x squared y squared. And I write them x to y because it doesn't matter. Plus y to the fourth. Combine like terms. X to the fourth minus 2x squared y squared plus y to the fourth. All right, I want to do